4:09 a.m. Persian Gulf, 37 nautical miles southwest of Bandar Abbas. A torpedo just entered the water, bearing directly on USS Carney. Not a missile, a torpedo, a weapon that travels underwater, beneath every layer of a ship's electromagnetic defenses, targeting the hull below the waterline where the armor is thinnest and the damage is worst. The USS Carney, an Arleigh-Burke-class guided missile destroyer, had been operating in the central Persian Gulf on a freedom of navigation mission when her hull-mounted SQS-53C active sonar detected the weapon at a range of approximately 1,100 meters, bearing 027 degrees. Speed, approximately 40 knots. Depth, 12 meters. A torpedo at 40 knots covers 1,100 meters in 66 seconds. The ship had 66 seconds to react. Welcome to Navy Powerline, where we break down the naval operations that define American power in the world's most contested waters. What you are about to hear is a reconstruction based on documented Iranian submarine doctrine, U.S. Navy anti-submarine warfare protocols, and Fifth Fleet operational assessments of the underwater threat in the Persian Gulf. Iran operates a fleet of Kilo-class submarines acquired from Russia in the 1990s, and a larger number of domestically produced midget submarines, specifically the Qadir and Fateh-class vessels, which are capable of operating in the shallow, complex acoustic environment of the Persian Gulf in ways that larger submarines cannot. The Persian Gulf is one of the worst anti-submarine warfare environments on the planet for the defender. It is shallow, averaging between 30 and 60 meters depth, with maximum depths of only about 90 meters in the central basin. It is thermally complex, multiple temperature layers that refract sonar energy in unpredictable ways. It is acoustically noisy. Heavy commercial traffic, shallow water biological noise, and the constant mechanical noise of oil platform infrastructure create a background that masks submarine acoustic signatures. A trained crew in a small submarine operating at low speed in the Persian Gulf can hide from detection systems that would locate them easily in open ocean. Iran built its midget submarine program specifically to exploit those conditions. The Qadir-class displaces approximately 120 tons submerged. It is approximately 29 meters long. It carries 2 torpedo tubes and a crew of between 8 and 14 personnel depending on mission configuration. Its diesel-electric propulsion can be operated at very low acoustic output. Its hull is coated with anechoic tiles that absorb sonar energy, reducing its acoustic reflectivity. At 4 knots in the central Persian Gulf at 4 a.m., a Qadir-class submarine is, in acoustic terms, difficult to distinguish from the surrounding ambient noise, which is exactly what the crew operating this one had been relying on. The submarine had been in the Persian Gulf for 11 days. It had transited from its home base at Bandar Abbas submerged, following the Iranian coast westward through shallow water where acoustic tracking by American assets was most degraded. Its mission, according to the post-engagement intelligence reconstruction, was not an immediate strike. For 11 days, the crew had been conducting a reconnaissance operation, following American patrol routes, cataloging transit patterns, and building a targeting picture. Then on day 11, they had received a fire order. The intelligence reconstruction of why the fire order came when it did, at 4:09 a.m. on that specific morning, remained incomplete in the unclassified assessment. What was known was that USS Carney had been following her standard patrol route in the central Gulf, and that the submarine had been in position to fire a torpedo on a favorable geometry for approximately 40 minutes before the weapon launched. The crew had waited. Why they waited 40 minutes before firing is a question that has 3 plausible answers and no confirmed one. First possibility, they were waiting for a specific element of USS Carney's transit that would place the destroyer at the optimal range and aspect angle for a torpedo shot. Second possibility, they received a delayed fire authorization from their command authority that arrived after the initial firing window opened. Third possibility, they had a technical issue, a torpedo tube malfunction, a navigation system anomaly that delayed the launch. The fourth possibility, that someone in the submarine's crew hesitated, was noted in the assessment and then set aside as unverifiable. None of these explanations change what happened at 4:09 a.m. The torpedo was in the water. USS Carney had 66 seconds. The SQS-53C sonar detection had already triggered the ship's torpedo warning system. The automated alert lit up in the Combat Information Center. The officer of the deck, Lieutenant Commander Paul Ferrara, received the warning at 4:09:14 and immediately transmitted to the entire ship on the 1MC announcing system. Torpedo in the water. Torpedo in the water. All hands brace for evasive maneuver. Ferrara ordered a full hard turn to starboard simultaneously with the announcement. The Arleigh Burke-class can execute an emergency turn at nearly its maximum speed of 31 knots, turning hard enough to present its stern aspect to an inbound weapon, which reduces the acoustic return that a homing torpedo seeker can track, and changes the closing geometry to reduce impact probability. At the same moment, the ship's AN/SLQ-25 NIXIE torpedo countermeasure was deployed. The NIXIE is a towed acoustic decoy. It generates signals designed to mimic the acoustic signature of a large warship, drawing a homing torpedo seeker away from the actual hull. The NIXIE was in the water at 4:09:31, 17 seconds after the torpedo was first detected. The torpedo had been in the water for 31 seconds. It was at approximately 780 meters, still on original bearing. For the next 28 seconds, USS Carney was in a race between physics and engineering. The torpedo's seeker was running in passive homing mode, following the acoustic signature of the destroyer's propulsion. The NIXIE generates a competing acoustic signature. The question of whether the torpedo would track to the NIXIE or remain on the ship's propulsion signature depends on the torpedo's seeker design, the quality of the NIXIE's signature emulation, and the geometry of the engagement. Specifically, whether the NIXIE was deployed far enough astern to be acoustically louder to the torpedo than the ship's propulsion plant. At 4:09:52, 43 seconds after initial detection, the torpedo altered course, slightly, approximately 4 degrees to the right of its original bearing. 4 degrees at 780 meters is a small number, but 4 degrees sustained over the remaining flight time was enough to tell the sonar technicians watching the track that something had changed. The weapon was no longer tracking directly on the ship's hull. It was tracking on the NIXIE. The torpedo impacted the NIXIE towed decoy at 4:10:19. 70 seconds after it had entered the water. The explosion detonated at approximately 340 meters astern of USS Carney. The shockwave reached the ship's hull. The underwater pressure pulse was strong enough to trip circuit breakers in 2 engineering spaces, knock a sailor off a ladder in the main engineering compartment. He sustained a broken wrist, and cause a momentary loss of power to one radar system, which reset and came back online in 44 seconds. No one died. The decoy had absorbed the weapon, but the submarine that had fired that torpedo was still in the water, still submerged, still at a position that was somewhere within a several-mile radius of the torpedo launch point, and moving to evade the counterattack it knew was coming. Commander Wesley Barrett, USS Carney's commanding officer, had been in the Combat Information Center when the torpedo alert sounded. He had watched the engagement play out in the CIC displays. The moment the torpedo detonation registered, aft, not on the hull, he was already calling Fifth Fleet. He had 2 immediate needs. First, an accurate position for the submarine. The SQS-53C had held a contact bearing during the torpedo run, but the track quality had degraded as the evasive maneuver had changed the ship's sonar geometry. The last solid fix on the submarine was 1,100 meters bearing 027 degrees, but the sub had been moving during the engagement and could now be anywhere within a radius of approximately 2,000 meters from that position. Second, assets to hunt it. A ship's hull-mounted sonar is not the right tool for a close-range ASW hunt in shallow water. It is the tool you have when nothing else is available. The right tool is a helicopter. Both MH-60R Seahawks assigned to USS Carney were on deck. Both crews had been at crew rest, as in sleeping, when the torpedo alert sounded. Combat readiness protocols required both aircraft to be launch-capable within 15 minutes of an alert. In practice, the Seahawk crews were strapping in at 4:11:45, 2 minutes and 31 seconds after the torpedo detonation. First seat, 5 minutes and 53 seconds from torpedo impact to first helicopter airborne. 5 minutes and 53 seconds during which the submarine's crew had been driving as fast as they could in whatever direction they had chosen, trying to open the range and reach acoustic cover before the helicopters arrived. A Qadir-class submarine at maximum submerged speed moves at approximately 11 knots. In 5 minutes and 53 seconds, it could have covered approximately 1 nautical mile from the launch position. Shadow 4's crew had the last known position of the submarine. They had a search radius, 1 nautical mile from the last fix, expanded for the elapsed time. They had 2 AQS-22 dipping sonars and 2 Mark 54 lightweight torpedoes. The hunt began. The central Persian Gulf at 4:15 a.m. is an acoustic nightmare. The thermal layers that refract sonar energy sit at varying depths depending on the day, the current, and the salinity gradient. The first dip by Shadow 4 at 4:17:11, 800 meters northeast of the last known position, came back with multiple contacts. 4 of them. In a shallow environment with complex bottom returns, multiple contacts are standard. 3 are usually the seabed. 1 might be the submarine, or all 4 are the seabed. The crew at 4:19:44, Shadow 4's passive sonar detected a contact that didn't fit any geological profile. It was at 31 meters depth, on a bearing of 041 degrees from the dip position. The acoustic signature showed a slow rotation, consistent with an electric motor at low power, consistent with a submarine trying to run quietly, not consistent with a rocky bottom. Shadow 4 held the contact for 41 seconds. The bearing did not drift. The contact was either stationary or moving extremely slowly, trying to make as little noise as possible. It was the submarine. This is the moment where the engagement reached its most consequential decision point. Shadow 4's crew had a valid target. They had 2 Mark 54 torpedoes. They had positive contact. Under Fifth Fleet rules of engagement, a submarine that has conducted a hostile attack on a U.S. warship is a valid target for immediate destruction. But here was the complication that Petty Officer First Class Maria Reyes, the acoustic sensor operator in Shadow 4, flagged at 4:20:26. The contact was not moving toward USS Carney. It was moving away from the formation toward the Iranian coast at approximately 3 knots. It was conducting no apparent aggressive behavior at the moment of contact acquisition. The torpedo had already been fired and had already detonated. The question of whether a submarine that has already fired is an ongoing threat or a retreating vessel, and what that distinction means for ROE application, is not a question that a Seahawk crew resolves at 4 in the morning at 31 meters depth over a Persian Gulf contact. Shadow 4's crew transmitted to USS Carney at 04:20:44. Positive contact, bearing 041, depth 31 meters, contact moving northwest, at approximately 3 knots, awaiting weapons authorization. Commander Barrett relayed to Fifth Fleet at 4:20:51. Authorization came back at 4:21:14. Fire. Shadow 4 transitioned to attack profile at 04:21:15. The Mark 54 lightweight torpedo, a wire-guided weapon with both active and passive homing modes, deployed at 04:21:44 from an altitude of approximately 60 feet above the water. The Mark 54 entered the water, its propulsion activated, its seeker searched. At 4:22:09, the sonar display in Shadow 4 showed the contact accelerating. The submarine crew had detected the torpedo in the water and had gone to maximum speed, 11 knots, running northwest. The Persian Gulf at this location was 51 meters deep, not enough depth to dive under a thermal layer, not enough room to maneuver significantly in 3 dimensions. The Mark 54 tracked the acoustic source, detonation at 4:22:41. The explosion was visible from Shadow 5's crew as a dark upwelling of water followed by a surface disturbance approximately 600 meters northwest of Shadow 4's dip position. The acoustic signature from the event registered as a catastrophic hull breach, the kind of pressure event generated when a sealed metal vessel is penetrated by a shaped charge at depth. The submarine did not surface. No crew members appeared. Shadow 5 conducted a debris scan of the area for 41 minutes. The scan located oil slick, mechanical debris consistent with a small submarine, aluminum hull sections, a pressure-suited component that was later assessed as part of an escape trunk assembly, and several smaller items. No survivors were observed. The submarine had been destroyed. The after-action assessment addressed several questions about the engagement that had implications beyond the tactical outcome. The first question was the 40-minute delay between the submarine reaching an optimal firing position and the actual torpedo launch. The signals intelligence assessment, completed over the following 10 days, suggested that the submarine's fire order had been transmitted from a command authority ashore, and that the order had taken longer to arrive than the planning timeline had anticipated. The delay was attributed to a communications relay problem between the IRGCN Naval Command in Bandar Abbas and the submarine's VLF radio reception capability in the Gulf's shallow water. The submarine had been ready to fire for 40 minutes. The authorization had been delayed 40 minutes. If the authorization had arrived on schedule, USS Carney would have received the torpedo alert while it was at a different point on its patrol route. one where the NIXIE deployment geometry would have been less favorable, because the ship's course at that time would have placed the decoy closer to the ship's beam rather than its stern. The torpedo might have tracked the hull instead of the NIXIE. 40 minutes of communications delay in a command system had been the difference. The second question was the NIXIE's performance. The decoy had functioned correctly. The torpedo had tracked to it and detonated at 340 meters astern. But post-engagement analysis raised a question about what would have happened if the torpedo had been one of Iran's more modern variants, specifically a wire-guided weapon that could have received course corrections from the submarine's crew after launch. A wire-guided torpedo does not need to follow an acoustic decoy. It follows the wire. Iran's newer submarine-launched torpedoes include wire-guided variants. The Qadir crew's choice to fire an acoustic homing weapon, rather than a wire-guided weapon, may have been driven by the weapon loadout aboard the specific submarine, or by a tactical decision, or by equipment status. The question of what weapon Iran's submarine fleet will use in future engagements remains open. USS Carney completed repairs in Bahrain over 4 days. The circuit breaker resets were addressed. The sailor with the broken wrist was treated and placed on light duty for 3 weeks. The NIXIE system was restocked with a new towed decoy. The ship was back on patrol in the central Persian Gulf 8 days after the engagement. The Persian Gulf is 40 meters deep on average. Every U.S. warship that transits it is operating in a bathtub compared to the open ocean. The acoustic environment that protects Iranian midget submarines also limits the range at which those submarines can receive command communications. The delay that cost the submarine crew their optimal firing window was built into the physics of the operating environment. But physics also limits the NIXIE's effectiveness against wire-guided weapons. And Iran has been building wire-guided torpedo capability into its submarine fleet since 2015. The wire-guided torpedo problem is not theoretical. It is documented in Iranian naval exercises observed by U.S. intelligence assets. The IRGCN has conducted live-fire exercises with wire-guided torpedo variants from Qadir-class submarines in the Caspian Sea and in deeper waters of the Gulf of Oman, where the wire length is sufficient for effective guidance. The weapons exist. They have been tested. Their integration into active fleet operations is assessed as ongoing. What the NIXIE decoy system does against an acoustic homer, it cannot do against a wire-guided weapon controlled by a submarine crew watching a sonar picture. The wire-guided torpedo follows human judgment, not acoustic signature. It can be steered around a decoy. It can be re-aimed if the initial bearing is slightly off. It is a smarter weapon in the hands of a crew that is watching the engagement play out. The Qadir crew that fired at USS Carney did not use a wire-guided weapon. The reasons for that choice are unknown. It may have been the weapon loaded on the specific torpedo tube that was operationally ready. It may have been a tactical preference. It may have been that the wire-guided variant had a shorter operational range that didn't fit the engagement geometry. None of these explanations have been confirmed. What is confirmed is that the next submarine, the next crew, the next patrol, the next 40 minutes of waiting for a fire order, may make a different equipment choice. Fifth Fleet's anti-submarine warfare posture in the Persian Gulf was formally reviewed within 30 days of the engagement. The review produced 2 significant changes to standing operating procedures. The first change was to the NIXIE deployment protocol. Previously, the NIXIE was deployed as a response measure after torpedo detection. The revised protocol authorized pre-deployment of the NIXIE during high-threat transits, specifically when passing through the central Persian Gulf acoustic environment during known periods of elevated IRGCN submarine activity. Running the NIXIE continuously during transit adds operational wear to the system, requires more frequent decoy replacement, and broadcasts a continuous acoustic signature of its own. The operational cost was accepted as worthwhile given the detection to deployment timeline problem the engagement had revealed. 66 seconds from torpedo detection to NIXIE detonation is a very thin window. The second change was to helicopter crew alert status. At the time of the engagement, both Seahawk crews were at crew rest. They achieved launch in 5 minutes and 53 seconds, which is within the design standard. The review concluded that during high-threat transits in the Central Gulf, at least one helicopter crew should be at cockpit alert status, meaning seated in the aircraft, pre-flight complete, ready to engage the rotor in under 60 seconds. That change adds crew fatigue. Long transits with one crew at cockpit alert and the other at rest, rotating in shifts, is operationally demanding. but it reduces the gap between torpedo detonation and first helicopter on station from approximately 6 minutes to approximately 90 seconds. 90 seconds of additional time to establish a contact on a fleeing submarine can be the difference between catching it and losing it. Both protocol changes were implemented. Both added operational burden. Both were accepted. Iran did not publicly acknowledge the loss of a submarine. No statement was issued. No memorial ceremony was announced. The families of the crew received notification through internal IRGCN administrative channels at an unknown date. 8 weeks after the engagement, a new Qadir-class submarine was observed departing Bandar Abbas on what imagery analysts assessed as a training patrol. The Persian Gulf is still 40 meters deep on average. The acoustic environment is still complex. The IRGCN still has submarines. Stay vigilant. Stay informed. See you in the next one.